Polyatomic ions. So this is what you get when different groups of atoms get together and the group as a whole has a charge. So it's not just one element that gets a charge, it's a group of atoms that get together and as a combination they have a certain charge. And then they can combine with other elements or other polyatomic ions to form compounds. So the first one, the way you know you're dealing with a polyatomic ion is if you look, we have 3 capital letters. So there's more than 2 elements. Anytime there's more than 2 elements, you have at least one polyatomic ion. In this case, NH4, if you look it up on the chart in your notes, NH4 has the name ammonium. So you just write ammonium. And chlorine, remember, becomes chloride. So again, the fact that there's a 4 here has nothing to do with the name. This is not nitrogen, hydrogen, chloride. It's ammonium. That's the name of this whole group of atoms. And then the other element is chlorine, which becomes chloride. So ammonium chloride. Again, we've got more than 2 elements. So we've got a polyatomic ion. Well, the first thing here is aluminum. And then the second part is C and N together. That polyatomic ion is called cyanide. So this is aluminum cyanide. And again, the fact that there's a parentheses and a number 3 here doesn't affect the name. CaCO3, 3 elements, polyatomic ion. Calcium is the first element in the compound. CO3 is a polyatomic ion called carbonate. Okay, so we don't change the name of the second thing when it's a polyatomic ion like this. So we don't change carbonate to carbonide. You just write whatever the name is, don't change anything with it. Okay, lithium, 1 element, and then S and O, sulfur and oxygen together. And here's where the number does matter, because there are 2 different polyatomic ions that have sulfur and oxygen in them. We start with lithium, that's the easy part, it's just the element name. And then SO3, which has a charge of -2, is called sulfite. If it was SO4 with a 2-, that's called sulfate. So this is where you have to pay attention to the little numbers. Make sure you check on the chart. Some of these combinations have more than one version, and the names are different depending on the exact formula of the polyatomic ion. So SO3 is sulfite, so this compound is lithium sulfite. Now to go the other way, lithium acetate. All right, so lithium, that's Li. Acetate is a polyatomic ion that has the formula of C2H3O2, and it has a charge of -1. Well, lithium is a +1. It's a group 1 element, so it's got a charge of +1. So the charges here match, which means I only need 1 lithium and 1 acetate to make the compound neutral. So that's all you have to do. Write the symbol for the first element, write the entire formula for the polyatomic ion. You'd have to look up the name acetate to know that it's C2H3O2. But then once you know the charges, if they're equal, you just put them together. Beryllium hydroxide. Beryllium is a +2. Hydroxide is a polyatomic ion made of oxygen and hydrogen. It has a charge of -1. So now the charges don't match. When I switch the numbers, the 1 from hydroxide goes to beryllium. Now I cannot change the formula of hydroxide. I can't just put O2H2. That's not the same thing. But what I do is I put parentheses around the ion and then take the 2 and put that outside the parentheses. So beryllium hydroxide has this formula, Be parentheses OH close parentheses 2. Ammonium oxide. Ammonium is NH4 with a charge of +1. Oxygen, oxide is -2. So here we're going to need 2 hydroxides. And we do that by putting the NH4 in parentheses with a 2 and then the O for oxygen. Potassium hydroxide. Potassium is a +1. Hydroxide is a -1. Since the charges match, I can just write KOH and be done.